We now know, and we've seen it, that when you use big f-stop numbers, the opening is actually really small. When you use small f-stop numbers, the opening is really big. And that, again, that seems contrary. I think we need to understand why. Right? Let's talk about the why. First of all, we need to understand what the word f-stop refers to. Why is there an f in f-stop? Does anybody know? Well, that's actually not full stop because these shutter speeds are also full stops. So the f in f-stop doesn't refer to full stop because actually there are settings between these full stops called half stops. The f in f-stop is because an f-stop is a focal length ratio. Please write that in your notes. These numbers, 5.6, 8, 11, 16, these are ratios. They specifically are focal length ratios. That's why we use the term f for f-stop. Focal length ratios. So there's a little bit of math here. I'm sorry if you don't like math very much, but there is. I'm going to explain it two ways. I'm going to explain it algebraically, a little bit of math, but I'm also going to explain it visually with some pictures. And so hopefully one of the two will make sense to you, okay? I like math, so I'm going to go through math first. Let me go ahead and turn off my projector, though, because I'm going to draw some stuff on the board. So first we need the equation, because these numbers, we get to them by doing a little bit of math. Shutter speeds are easy to understand. Shutter speed of 30, a 30th of a second. Shutter speed of 2, half a second. F-stop of 11, that seems like an arbitrary number. All right, so let's talk about it. So let me give you the equation. This needs to be in your notes. I will test you on this. F-stop, or the F-stop number, so these numbers, F-stop number equals focal length of the lens. So I'm just going to write focal length, but when I say focal length, I'm referring to the focal length of the lens measured in millimeters. Remember, whenever we talk about focal lengths, we're talking about them in millimeters. So if I zoom in, I might zoom into 200 millimeters, or I might zoom out to 18 millimeters. So we're talking about the length of the lens, right? So f-stop is equal to the focal length of the lens. Remember, this is a ratio. A ratio is always one number divided by another number. F-stop is equal to the focal length divided by the diameter of the aperture. Again, measured in millimeters. The diameter of the aperture measured in millimeters. Okay, so far so good? So it's one number divided by another number. Okay. So if we have our camera here, right? So this is our camera.
How do you spell aperture?
A-P-E-R-T-U-R-E. I spell Aperture.
Because on the slideshow it said A-P-E-R-A.
That's a misspelling.
Okay.
It's yeah. Sometimes even I misspell it. It's A-P-E-R-T-U-R-E.
Okay.
It's not aperture, it's aperture.
I don't know why I always want to say that.
I do too. And so since I created those presentations, I may have misspelled it. All right, so we have our camera here, right? Remember, where is the aperture found? In the lens housing, right? So if I have my camera here, and if it's kind of sitting sideways there, right? So if we have the side view of my camera, so here's my lens here up front, correct? So if I'm taking a picture, so here's my subject over here, I'm taking a picture of this little stick figure guy. The light comes in through my lens, correct? And then as that light travels through the lens, remember lenses refract light, right? They bend it. That light comes to a point, right? That's our focal point, or this is where our focal plane is located, right? So in our camera, this would be where we put our film, right? Or in a digital camera, this is where our recording medium is. So far, so good? If you remember earlier, we talked about the definition of focal length. Focal length would be if I took a ruler and I literally measured the distance from the lens to the focal point. That is focal length. And when you zoom, you're changing that, right? When you zoom the lens actually moves forward and back, changing the focal length. Let's say right now, we have the focal length set at, let's say we have it set at about 50 millimeters, 50 millimeters. So far, so good? You with me so far? Okay. So looking at our equation, remember we need two numbers to get the f-stop, right? What are the two numbers I need to get this number? I need the focal length of the lens, and I need the diameter. I just told you that we have the focal length set at 50. So could we not plug that into our equation here? We could, right? So f-stop equals 50 millimeters divided by, what's the other number I need in my equation? The diameter of the aperture. Grab your lens. Everybody grab your lens. The film camera lens. With me so far? Grab the film camera lens. I want you to adjust the aperture to around 8, f8. It's about in the middle. So in our apertures, f8, that's about middle of the road. So far, so good? Now, because not all of us are used to the metric system and thinking in millimeters, you need to get used to it. So a quick refresher. This stick is a meter stick. It's 1 meter in length, right? In photography, we need to stop thinking in terms of feet and yards and miles, but rather to be thinking in terms of meters, millimeters, centimeters, kilometers. So this is a meter. Now, for reference, 1 meter is about 1 yard. So a meter and a yard are about the same size. You with me so far? If we were measuring my height, you know, we could say, okay, he's a little under 2 meters. If we wanted to be more precise than that, though, we could break this into smaller units. If we were to take this meter stick and slice it into 100 small segments, now each of those small segments would be a centimeter. Centi, C-E-N-T-I, that means 1/100th of a meter. Visually, to help you understand, if you hold up your pinky, everybody hold up your pinky finger. The width of your pinky finger from side to side, that's about a centimeter. About a centimeter. Okay. So that means, again, if we were to divide this into 100 small segments, each of those is a centimeter, meaning I could probably line up 100 of my pinkies in that distance. Are we with me so far? So that's centimeters. But millimeters are even smaller. Milli means 1/1000. So that means if I have a meter stick and I slice it not into 100 sections, but if I slice it into 1,000 small sections, each of those small sections is 1 millimeter. All right? To give you an idea, again, I'm a visual learner. I need like some sort of way to think about it. A millimeter. A millimeter, if you were to take like a dime, like in your pocket, pull a dime out, not the width of the dime, but if you were to hold the dime on edge, so the thickness of a dime is about 1 millimeter wide, right? So that means you could take, if you took 1,000 dimes, if you were able to stack up 1,000 dimes, 1,000 dimes would be about the height of this stick, because again, this is 1 meter. There are 1,000 millimeters in 1 meter. We moved so far? Another way to think about it, which I prefer, pasta. You know the really teeny tiny like vermicelli or the angel hair spaghetti noodles? Those are about 1 millimeter wide. Or even if you have a mechanical pencil, the lead that's in your mechanical pencil, that's almost 1 millimeter. Are you with me so far? I need you to visualize that for this to make sense. Okay? So visualize the teeny tiny spaghetti noodles. Not the thick ones, the teeny tiny ones. Okay, grab your lens again. Right now, you all have your lens set at f8, correct? So I want you to imagine, looking at the size of the opening here. So I'm looking through the lens at the opening. Imagine if you were to take pasta noodles. How many do you think, like side by side, of those really thin angel hair pasta noodles you could put through here with the aperture set at f8? What we're doing is we're estimating the diameter of that opening. Right? So as you're looking through the lens, right, you see the opening of the aperture, it's this size, right? So if you were to try to estimate how wide this is, About how wide do you think it is?
10.
Not quite 10.
30.
Definitely not 30.
If you fit 'em all.
I would say it's about 5 or 6.
Oh,
5 or 6. Now, I know it's about 5 or 6 because actually I know mathematically it's going to come out to about 6.
I was gonna say, you
Right.
actually tried it. That would be super cool.
I don't know for sure how wide it is, but I could calculate it. Remember our equation? Fstop equals focal length divided by diameter. I don't know for sure the diameter, but I am kind of estimating it right now to be about 6. What we do know, though, is currently you have your aperture set at what? 8. You actually could put that in the equation here, couldn't you? All right, couldn't we actually put 8 right here? Because you have the actual lens set at f8. What we don't know, but what we're actually estimating right now is technically this number. We could actually calculate it, though, if we wanted to, by putting a variable there. We could just put an x right there to represent the diameter of the aperture. If we did some math then, right? If we're dividing x on this side and we want to move the x, what we want to do then is to multiply both sides by x. So if I move the x over here, by multiplying both sides by x, this x and this x are going to cancel out. And what I'm going to be left with is 8x equals 50 millimeters. If I want to get the x by itself, I do what? I divide both sides by 8. So that means x is going to equal 50 millimeters divided by 8. And if you do the math, it comes out to about 6.2. So when I said before that the opening of your aperture at f8 is approximately 6 millimeters wide, I wasn't lying to you. Make sense? Sort of. Okay. Hopefully it will when we get done. What's going to happen, though, when I change the f-stop? What if I change the f-stop? Right now it's at 8, correct? What if I changed it to 22? First of all, from what you've seen and what you know, is the aperture going to get wider or narrower? It's going to get narrower, because we've already seen that. In fact, actually, please adjust your f-stop to 22. Adjust your f-stop to 22 for me, please. Again, you guys, I'm going to explain this algebraically, but again, I promise I'm going to explain it visually too. Okay? When you went from f8, which is about halfway open, halfway closed, midway, to 22, the aperture did suddenly what? It shrunk down more. So the opening got smaller, tighter. Again, if you were to hold up the lens in front of you, so let me adjust my aperture to 22. As I went from 8 to 22, suddenly that opening got very, very narrow. Again, using the idea of trying to feed some pasta noodles through there, about how many do you think you could probably fit through there? Maybe 2. About 2. Because it's pretty narrow, right? Again, going back to our equation, what stays the same in this equation? What did I not adjust? The focal length still stayed at 50, correct? So in terms of my equation, remember f-stop equals focal length. Well, we kept the focal length at 50, so that stays the same, 50. What did we change, though? We did change the f-stop. We had it at 8, and we changed it to what? 22. And as we changed this number, what else also changed? The diameter changed. It got smaller. Again, right now we're estimating it to be around 2, but we can calculate it, right? We just put x as a variable and calculate it algebraically. Again, if we move the x to the other side, we're going to get 22x equals 50 millimeters.
2.27.
It comes out to, thank you, Anna, for doing that math for me. If we take at 50 divided by 22, it's going to come out to about 2.2 something, or approximately 2 millimeters. I'll get you, hold on a second, Della. Let me make the point first, and I'll promise I'll come to your question. The relationship between f-stop and diameter, this ratio is kind of like an inverse one. Meaning that when one goes up, the other goes down. So if this number, the f-stop number, gets bigger, then the diameter has to get smaller. That's why using f-stop numbers that are big results in openings that are small. Because it is a ratio. So it's important to remember, when we say we're using F11, we don't mean the size of the opening is 11 millimeters. It's a ratio of the length divided by the aperture. Now, let me explain this one other way. Okay? Whenever you have a ratio, you're comparing one thing to another thing, right? How big is this when we compare it to this? What are we comparing? How long is the focal length compared to the size of the aperture opening? So let's say I'm looking through my lens, and I have my aperture, and let's say it's this wide right here. All right? I don't know what f-stop number that is, but I could figure it out. Let's say I know for sure that my focal length is set here. Remember, f-stop number. These numbers are based upon comparing focal length to diameter of aperture. In other words, I'm comparing this length to this opening. Or in other words, how many of these circles can I fit in this distance? If I can fit 1, 2, 3, 4, 5, 6, 7, 8, then we would say that this is F8. What if I opened up the aperture farther? What if instead of having an aperture this size, what if I changed it and I opened it up really far? Is the number, the f-stop number, if the opening got bigger, is the number going to get bigger or smaller? It's actually going to get smaller. Remember, we're comparing this distance to this size. In other words, how many of these circles can I fit? 1, 2, 3, 4. So this opening would be F4. How big would the opening be if I was using F2? Would it be even wider or would it be narrower? It would be even wider. F2 would be almost all the way open, where I could fit 1, 2 of those in that distance. Ultimately, if none of that made a bit of sense, there's one thing I want you to remember. Big numbers mean less light. If this ratio stuff didn't make a great deal of sense, that's okay. That's a little bit more advanced photography. The reason I teach it to you, though, is when I took photography way back when, I had a teacher that told me, F22 just means it's a really small opening. And when I asked the question, well, why? That doesn't make sense to me. I would think that a big number means it's a big opening. He just said, don't worry about it. That's just how it is. And that drove me nuts. I wanted to know why. How come 22 means that the opening is so small, and 2 means the opening is so big? The reason is this. It's a ratio. Ultimately, the biggest thing to remember is big numbers result in very small openings, which ultimately result in what? Less light. So if you're taking photos outside on a really bright sunny day where you have too much light, what are you going to do with your aperture? You're going to want to close it down. So in terms of numbers, are you going to pick small numbers or big numbers? You're going to pick bigger numbers. On the other hand, if you're at a crime scene and it's dark and you don't have a lot of light, now you need more light. So that means you're going to have to open up your aperture farther. Opening up your aperture, is that going to be using bigger numbers or smaller numbers? Smaller numbers. Does that make sense?